So we've been graphing quadratics and cubics, so now we're going to learn how to graph any type of polynomial. So we're going to call it a polynomial with the letter x. Polynomials have these little values out in front, which we're going to call coefficients, and those values change. They could be the same, but I'm going to put n minus 1 to say it'd be the next coefficient, and the values of the power of x decrease, and this continues on until I get to my very last term, which would be a sub 0, which is just a constant. So my coefficients, once again, are these values out in front, so these a's, and don't let these little subscripts worry you. It's just saying that I have these different a values. My constant term is something without the variable, so that's a0, it's the very last term, and my leading term is my first term. So recall each of these are terms. And we call it my first term because it's in front, it's leading. And if you think about how we always organize our polynomials, we always start with the largest power in the beginning. So my leading term would be this value, a sub n, which is a coefficient, and then x to the power of n. So the degree of my polynomial comes from the leading term, and the degree is just going to be that largest power. And it's really going to tell us a lot about our polynomial and its graph. For example, when we were looking at quadratics, my leading term was an x squared, so I knew it had this shape. When I was looking at cubics, whatever happened to be behind it, this power 3 told me that I had that chair shape. And those are the things that we're going to start graphing. Zeros of a polynomial help us as well. It's when my polynomial is equal to 0. We've solved those before. For example, when I had a quadratic, we had something like this equal to 0. So I had two solutions, the -2 and the +1. And that's where it hits my x-axis, called my x-intercept. Sometimes we call them also solutions, roots, x-intercept. Those are all called the zeros. And what do they look like? Well, in a quadratic, we had a couple cases, and that's what we're going to have to be thinking about. It's not always going to hit twice. In a quadratic, it can hit once or none at all. So it varies by the polynomial on how many times it's going to intersect. So how did I find these things? Well, we had two methods. We either used the quadratic formula or we factored. I'm just going to go ahead and factor this because I could see that, let's see, x minus 8 and x plus 2 would be equal to 0. So we set those two equations up, and I see that +8 and -2. Many of us can just look at that now and kind of tell what's going on. In the next scenario, this 4 right here tells me how many solutions I'm going to have. Notice this was a 2 and I had 2. So I could possibly have 4 solutions to this. So if I'm going to go ahead and try to factor this, I think the first step of factoring is to take out the largest exponent. I'm also going to take out that negative. So the largest exponent in each one of those would just be x squared. So I have a 2x. I took out the negative and 2 of those x's, so I'm left with 1. And then I took out the x squared, but I also took out a negative. So if you redistribute, you need to see that that actually matches. And I think I better have a power of 2 on that. So factoring this further, so we're going to be reviewing some of our factoring. And factoring this further, it looks like I get a +3 in here and a -1. If I'm checking that, it looks like it works. And so I've got some answers here, and so they would be -x squared equal to 0, 2x plus 3 equal to 0, and x minus 1 equal to 0. So we thought we would have 4 answers. I have an answer here, +1. I have an answer here, which is -3/2. And believe it or not, I have 2 answers here, and they are both 0, because x is equal to 0 twice. So sometimes the factoring gets a little tricky. You might think, oh, I've never factored a cubic before, but you actually have. We're going to go ahead and group the first two terms. Notice this is a -4 that I'm grouping. Taking out an x squared, I've got an x minus 2 left. Taking out a -4, I'm left with x minus 2 again. So x minus 2 gets factored out of x squared minus 4. Notice there it is. This is factored by grouping that we did on our first exam. So I've got x minus 2. I've got x plus 2 from this set and x minus 2. So I get what I thought, 3 solutions. And those solutions, if we look here, would be a +2, a -2, and once again a +2. We have two values at +2, which is fine. It just means that it gets duplicated. Looking a little bit deeper at these graphs, if I have even powers, we talked about even powers, and we talked about that symmetry idea, that it would be symmetric about the y-axis. However, we're just looking at the even degree, not just all even powers, but an even degree, something such as x squared plus 2x, y equals x to the 4th plus x. We can see that those aren't even graphs, but once again, I'm looking at these powers called the leading term. And anytime that we have even powers like that, we're going to end up with some sort of a graph that looks like a parabola. Both ends are going to be going up, or we could have something like this, a bunch of bounces, and both ends going down. Regardless, the ends are going to go in the same direction. We call this end behavior. What happens on the ends? And it's that case because of the even power. It makes them all either positive, or something that's such like this would make them all the same direction but negative. So we're looking at these ends right in this case. And then if we have an odd degree, something like x cubed, we're going to get this kind of situation. You've been calling it a chair, but notice my ends go in the opposite directions. So I could even have something like this, that has an odd leading term, and it's odd because of the direction. So we have our idea like when x is going to infinity, my answer out, y is headed to the negative direction. If I look on this side, x is headed toward negative infinity. It's growing in the negative direction. Therefore, my y, in this case, is headed positive direction. So we just kind of look at what's happening as x gets super large. So we have two situations, either a U or a chair. And the last thing we need to talk about before we can graph these is a thing called multiplicity. Multiplicity, let's see, kind of has this word multiple. And what it means is it kind of like this idea of a multiple root or solution. It happens multiple times. So if I have something that's going to happen multiple times and it's odd, it might be something like this. It happens 3 times that it hits +2. So it's going to hit +2 3 times. And you might ask, well, how are you getting 3 times? Well, if I go ahead and expand out that cube, it's x minus 2, another x minus 2, and yet a third x minus 2. However, on my graph, how am I going to know that it hit this +2, this +2, and this +2 3 times? How am I going to know that? Well, what happens is this. I have an odd power. I have a chair situation. It's going to rest there for a count of 3. And so it kind of has this little flat spot. And notice with that flat spot, it's got this pass. I call it a pass through. Okay, it's going to change sign. If I have 3 negatives, it's going to be negative. If I have 3 positives, it's positive. So that's why it has a pass-through. So let's see what's going to happen if I had an even power on the same thing. Let's go x minus 2 to the power of 4. It's going to hit that 2 4 times. And here's why it hits 4 times. I have this x minus 2 4 times. So it's going to hit a 2, a 2, a 2, and a 2 4 different times. So here's my 2. It's going to hit it 4 times. Now, if I throw a negative in there or a positive, it's going to do something like this. Why is that? Well, if my graph is positive, positive to the 4th power is positive. If I wanted to go down, I would take a negative to the power of 4, which remains positive. So this has to flip up. So what is it going to look like? So I know that it's hitting 4 times. I know it's going to go to positive 2. So it comes down there. It's going to rest there 4 times. So it has a flat spot. It's got this flat spot. I kind of don't like how that graphed. It should be like really kind of squared off there. How did I know it was going to be a U? This power of 4, even power, tells me I'm going to get a U. So what we've got to do is put all of these things together so that we can graph a polynomial that looks like this. So just thinking about it before I begin, this is my clue right here. I know because it is an odd power, it's going to be those things that we've been calling a chair. I know that I'm going to have 3 possible solutions or roots. I know that because of that power of 3. So the first thing I'm going to do is I'm going to write it in factored form. So I'm going to take out an x. I've got x squared minus x minus 12. Continue factoring that, x minus 4 and x minus, how about x plus 3? So those are my 3 factors. For my 3 factors, I can see my 3 intercepts, and those are going to happen at 0, 0 from the x, 4, 0 from the second factor, and negative 3, 0 from the third. Notice I wrote those in ordered pairs. My y-intercept is easily found if I have my polynomial not factored. That happens when I put in a 0 for x. I can see I can get a 0 out for y. So the next thing we do are we're going to plot these points. I'm going to plot 0, 0. It's both an intercept on the x and y, 4, 0, and negative 3, 0. Now I'm not sure about my chair. I can see there are no bounces and no flat pass-throughs. There are no flat ones because these are just single pass-throughs. They're just powers of 1. But I'm not sure if my graph is going to go like this. Oh, I know it doesn't go like that because my power is odd, not even. So I know that one's not right. Maybe it goes something like that. It's one option. I know it's going to be a chair. A second option could be this, but I'm not sure which of those 2 we're going to use for this. So we have to kind of do this thing called build a table to figure out where my graph is positive, where my graph is negative. So my table, I'm looking at this in sections. So my table has essentially 3 sections. I need to go, what happens to my graph here? I know what happens right here. What happens to my graph in this middle section? And then I know what happens here. What happens to my graph in this next section? I know what happens here. And lastly, what happens to my graph in this 4th section? So to set up these sections, I'm going to go from negative infinity to my first point I know, which is right here, which is negative 3. And then from negative 3 to 0, I'm concerned, but I know what happens at 0, so I'm not going to include that in my interval. And then I've got to go from 0 to 4. I know what happens at 4, and then what happens in the last yellow section. Down the side is my polynomial. Now I've got it written two ways, unfactored or factored. So I'm going to be multiplying because I know when I multiply a positive times a negative, I know the result is negative. If I'm adding a positive plus a negative, I have no idea. It depends on the size. So this table only works for multiplication. So I have to multiply or keep the parts in multiplication form. So these are its factors. So looking at my table, I pick any value in this region and I plug it into my x, which keeps it negative. I plug it into my next term, which keeps it negative, and my last term, which keeps it negative, which is -1. I don't care what the values are, just the end result. Picking a value, plugging it in for x, plugging it in, subtracting 4, plugging it in and adding 3 turns it positive. Picking another value between 0 and 4. Notice I can't pick 0, 4. I know what happened there. +1, plug in for x. When I subtract 4, it's negative. When I add 3 onto 1, it's positive. And in the last region, they're all 3 positive. Now, I know for sure when I multiply 3 negatives, I get a negative. And I also know for a fact that if I have 2 negatives and a positive, it's going to result in a positive. In this region, when I multiply, I know their end results. So that's why it's multiplication. So my graph says I was negative in the first region. So the first region corresponds to this yellow, and I'm in the negative, so I'm down below. Then in the next region, the blue region, if you look here, runs from 0, -3 to 0, which is in this section here. So I know my graph is positive, so it bumps up. Then it's negative in this section, which maps to this green area, 0 to 4. And lastly, it goes here. So I know what my graph general shape is. I knew a lot just from knowing the leading coefficient and the leading power. Let's try one more. Nicely, this is already factored for me. I don't need to do any factoring. So I already know my x-intercepts. Now, many people look at -3 to be 0, x minus 3 cubed to be 0, and x plus 2 squared to be 0. This will never be true. -3 will never be equal to 0, so it is not a 0. From this one here, I see I get 3. And from the second one, I get -2. So regardless here, I only know I'm going to hit twice. If I was to expand this, multiply it all the way out, and I multiplied all these x's, I'd have x cubed times this x squared. I know my leading power is going to be 5, just by not even finishing multiplying, but I can see that. So I already know I'm going to have a chair, even though I only have a +3 and a -2. I'm positive it's going to be a chair. Finding my y-intercept means plugging in 0. So I plug 0 in to each of these, and I go ahead and simplify that. Well, it's going to be -3 times, plugging a 0 in, -27, because 3 cubed is 27, times 4, whatever that value is. It looks like it's fairly large in the positive direction. We could find that, but I just know it's going to be up in this region someplace, and it's so large it's probably not on the scale I gave you, which is fine because these are just sketching. Now multiplicity. If you recall, multiplicity is multiple times the root hits. This root hits 3 times. This one hits 2 times. This is going to be a bounce, and this is going to be a flat pass through. And the reason why it's passing through, 3 negatives will change my sign to be negative. 2 negatives will not change my sign. That's why I have a bounce. If I have a negative number twice, it's going to turn positive. It changes and bounces back up. A negative 3 times remains negative, so it continues on its path, but it pauses there for just a minute. So my function is made of negative 3. Yes, you need to include that in your table, even though it was not a root. Across the top are my regions. So I have these regions here. I'm going to go from negative infinity to negative 2. Negative 2, the next region I have is going to be positive 3. It's between these two marks here. I know I'm going to be positive just from my y-intercept, but we're going to double check that. Okay, plugging in a value. There's no value to plug in to negative 3. It is a constant. So those are going to remain negative. I'm going to plug in a negative 3. Plugging it in here gives me negative 6 cubed. I don't care what the answer is. I just know it's negative. I'm going to plug in 0 because it's a pretty friendly number. Again, a negative cubed is still a negative. And finally, when I get over here, 4 minus 3 is 1, cubed is positive. Plugging it into my second, anytime I square something, I don't even need to plug it in because it has an even power. An even number of negatives will be positive. Multiplying, that's strange. So it says I'm going to stay positive. So I'm going to hit this point, stay positive, come up here. But wait a minute, see that bounce? Does that match what we said that would happen over here? We said it would bounce, and it did in fact bounce. Then we're going to have to come down and hit this point because I knew that those were my intercepts. And then it goes negative. And notice this is a flat pass-through. So you don't just go like that. That is not a flat pass-through. It is a pass-through, but it's not a flat pass-through. So what does your graph do there? It comes down, hangs out there for a little while, and then continues down along its way. So we want to kind of make this a little bit more smooth of a curve, but that's what your graph is going to look like. Notice again, there is your flat pass, and right here is your bounce. And we knew it was going to do that. We just weren't sure if I started above. My table told me to, so that's how I know, or if I was going to start below. So your homework assignment is listed on the bottom of this sheet.